Hello everyone. Today we're looking at the problem fill a special grid, which was question 2 in a weekly contest 448. So the question reads that we're given a non-negative integer n representing a 2 by n times 2 by n grid. So we must fill the grid with integers from 0 to 2 to the 2 to the n minus 1 to make it special. A grid is special if it satisfies all the following conditions. So all numbers in the top right quadrant are smaller than those in the bottom right quadrant. All numbers in the bottom right quadrant are smaller than those in the bottom left quadrant. All numbers in the bottom left quadrant are smaller than those in the top left quadrant. Each of the quadrants is also a special grid. And what we want to do is return that special grid. A special note is that any 1 by 1 grid is special, so if we just have a single element, like a 1 by 1 grid, that is considered special as well. So the description is a bit confusing for this problem, but looking at an example can really clarify exactly what's going on. So we're given n equals 2. This means that we're going to have a 2 to the second size grid. So we're going to have 2 to the 2 here, right, which is 4. So you have a 4 by 4 grid. And what we basically said is that the quadrants have to be in increasing order going around this way, right? So this top right quadrant will be the least, this one next, this one next, and this one next. And you could see that that is true, right? The maximum in this quadrant here is less than the minimum in this quadrant here. Likewise, the maximum here, 7, is less than the minimum here, and so on and so forth. So really what we're doing is we're filling out this grid in a way that satisfies those conditions. You also see that within this quadrant here, we're breaking it down further into 4 quadrants, right? So we have this quadrant of 4 grids. We can break this itself down into 4 quadrants as well. So each of these, we said a 1 by 1 grid is special, and these count and make up our larger quadrant. So essentially what we're doing here is we need to fill out this entire grid in that way. And we can see that this is the formation that does that for us. So we have 0 to 3 in this grid, 4 to 7 in this grid, 8 to 11 in this grid, and 12 to 15 in this grid. And we have to make sure that the maximum here is less than the minimum in the subsequent grid. So a bit confusing, but basically what we need to do is just fill out the grid in this order. So I want to talk about 2 special edge cases that we need to consider in this case. So for n equals 0, right, this is the 1 by 1 grid case. So in this case, if n ever equals 0, we'll just always return this. There's no other possibility here. If there's a 0 grid, we're just going to return this value. Very simple. However, let's look at this n equals 1 grid. So when n equals 1, we're basically going to have a 2 by 2 grid, right? So 0, 1, 2, 3. So here, it's pretty easy to break this up, right? Because we have, essentially in this grid here, 4 quadrants, and we know exactly the order we need to fill them out. So we kind of just follow this path. So this n by 1 case is going to be important, and this is how we're really going to solve this problem. So we want to consider the case of n by 1. In this, we're just going to follow around and fill out the elements in order. And this is kind of how we're going to approach this problem as we solve it, using this n equals 1 case. So here we are looking at n equals 3. And what this means is that we're going to have 2 to the 3, 8. We're going to have an 8 by 8 grid here. You can see that we have 0, 1, 2, 3, 4, 5, 6, 7. So I've split this up into its quadrants, as you can see that written here. And just here, I have a little reminder of the order that we're doing things in. So top right, bottom left, top left is the order of increasing that we need to have our elements in. So let's think about how we can do this. So here, essentially what we have, and we break this up, is 4 by 4 grids, right? And what we said is that each of the quadrants in these grids also has to be a special grid. So you can kind of see the recursive nature of this problem. We have this larger grid split into quadrants. Each of those quadrants also has to be a special grid. So we can break these up. This quadrant can be broken up into 4 other special grids, and then this quadrant can be broken up into another 4 special grids. But you notice when we get to this case here, this is that 1 by 1 case we talked about before, where if we have a 1 by 1 grid or an n equals 1 grid, we know exactly the order we could fill these out, right? We can go 0, 1, 2, 3. So essentially what we've done is we're going to start with this outer grid, but we're going to go down recursively until we get to this n equals 1 case, and we're going to fill out the grid in that order. So then what we do is we'd come down here, and we do the same thing. So 4, 5, 6, 7, and then what we do is here, 8, 9, 10, 11, and so forth. So we're going to use recursion for this problem because, as you can see, what we're really doing is taking this larger grid and slowly breaking it down into smaller and smaller pieces until we get to this n equals 1 situation. So the tricky part is the actual implementation of how we do this. So the way we're going to do this is keep track of 4 things. We're going to keep track of the top, bottom, left, and right of the area that we are currently looking at. And this is going to start with just the edges of this grid, right? So in this 3 by 3 grid, we go from 0 to 7 from the y-axis, and then we're going to have 0 to 7 on the x as well. So our top is going to be 0, our bottom is going to be 7, representing this y, and left is going to be 0, and right is 7, representing the x. So how do we actually break this down into a smaller grid? So remember, we said that we want to do this top right here first, right? So how do we actually do this recursive call and get to this smaller grid? So the first thing we have to do is you'll see that our left is currently here, but we need to move our left to here. So what we need to do is change this left value. So how do we actually do this? Well, we can use this formula of left plus right divided by 2. And then this whole thing, we're going to add 1. So let's take a look at an example. So we're going to have 0 plus 7. So this is going to be 7 divided by 2 equals 3 plus 1 equals 4. So here you see that by taking the bounds of our left and right and applying this formula here, what we can do is get our new x value. Now the other thing we need to do is we also need to adjust our bottom, right? So our bottom is going to be down here. So this bottom is a bit simpler. So what we can do for the bottom is simply just take that bottom value and divide it by 2. So the bottom we can do 7 divided by 2 equals 3. So then 3 here becomes our new bottom. So you see here what we did is that we changed our left to here and our bottom to here. So now what happened is that our top is still going to be 0, our bottom is going to be 3, our left is going to be 4, and our right is still 7. So you can see that this is actually accurate, right? So our top is 0 and goes down to 3 here. Our left is 4 and goes up to 7. So we're basically going to use these two formulas, and using these, we can break it down. So we did this and we found this. So then basically what we do is we're going to pass all these new boundaries into our recursive call and shrink the size of the grid that we are looking at. So let's see what happens there. So now we're looking at just this quadrant here. And remember that this quadrant also has to be a special grid. So what this means is that we need to fill in this top right section first. But remember, we said previously that when we get to this 1 by 1 grid here, we can just fill these out in order, right? We know the order of these already, so there's really no point into breaking it down any further. This is as simple as a case as we can get besides the 1 by 1 case. So what we can simply do here is say, I have this 1 by 1 grid, so let's keep track of my current number, which is 0, and just start filling it in. So I'll have 0, then I can increment this up to 1. I'll put my 1 here. I'll increment this up to 2, put that there, and then go to 3, and increment this up to 3. So this is a variable we're going to keep track of as we go through the problem, and this is how we know which of our numbers we're going to put next. So now we've filled out this grid. There's nothing else to actually do here. So now what we need to do next is move to the bottom right. And why do we move to the bottom right? Well, this is because we have to go in order, right? We're going around in this direction. So let's now move to this grid. So how do we find the boundaries of this grid? So currently our left and right are 4 and 7, our top and bottom are 0 and 3. So in this case, we need to bring our top down, right? So how do we actually do this? Well, it's very similar to how we do this left and right calculation. So to bring the top down, we have to do the bottom plus the top divided by 2, and then all that plus 1. So we get 3 divided by 2 equals 1 plus 1 equals 2. So our new top becomes this down here, and we leave the bottom. Then similarly, we have to do this for the left and right here. And to do this, we have to move our left again. And that's the same formula as this. So we're going to take our 4 plus 7. We're going to equals 11. Divide this by 2 equals 5 plus 1 equals 6. So now our left becomes this. And you see now our boundaries are another 1 by 1 grid. Our top and bottom are 1 away, and our left and right are 1 away. So now we can do the same thing. Fill these out in order. 3, 4, 5, 6. So you'll see we're just going to follow this kind of pattern, and there are a couple formulas we can use to generalize how we actually come up with these values. So really we can break this entire problem down into just 2 formulas basically. So to get our top and left, we're basically going to take the 2 boundary values, divide them by 2, and then add 1 to that. So you'll see for the top, we're just using the top and bottom, dividing them by 2, and then adding 1. The left is very similar. We're taking left and right, dividing them by 2, and adding 1. To get the bottom, we just take the top and bottom divided by 2, and for the right, we take the left plus right and divide it by 2. So really the only difference is this plus 1 here, right? So basically, to get the new values, we're just going to take the current boundaries, add them together, and divide them by 2. So you'll see here we do top plus bottom divided by 2. But if we want to get the top or left, we just add a 1 onto the end. So really there's just 2 formulas you have to know, and they're basically exactly the same besides adding this plus 1 for the top and the left. So what is the time complexity of this problem? Well, I would say it's O of the 2 to the n, and then this entire thing squared. And this seems like a very bad time complexity, but keep in mind that the max n value is going to be 10 in this problem, so it's something that we can get away with. And the reason why it's 2 to the n squared is because, say for example, we have n equals 3. Well, we know that we're going to have a grid of the size 2 to the n, which equals 8, right? But this is only one side. We need to do 8 times 8, which is a grid which has 64 elements, right? So really what we're doing is we have to go through each of these cells once. So we take 2 to the n to get the side of one of the grids, and then multiply this by itself to get the total number of cells that we have to look at. So it's O of 2 to the n to get one side, and then square that to account for all of the cells in the grid. Let's hop over to the code and see exactly how this works. So the first thing I do is set up this special edge case. So if n equals 0, I just return that grid. This is a kind of an edge case I don't want to worry about, so we just handle it up here. Then we set this current number variable, and this is what we're going to use to track the next number that we have to fill in. Since we are doing this recursively, it's going to be hard to keep track of that number as we go down recursive call, so it's easier to just keep an external variable here. Then we set up our grid. I start my grid with none in there. You could start with maybe -1 or something else. Basically what I'm doing is setting up this 2D grid, and I'm basing the size of that on 2 to the n. So there's going to be 2 to the n rows, and each of those rows will be of size 2 to the n. Then I'm going to do my main fill grid function, and this is where I actually do that logic. So I'm going to take in a couple things, top, bottom, left, and right, as well as that actual grid I'm going to fill in. So then I'm going to do non-local current num. This basically makes it so that I can modify this current number variable from inside this function, because it's something that I'm going to need to reference to add multiple recursive calls that I don't want to keep track of in the state of the recursion. So I'm just going to add this here so that I can update it easily from within here and access it. So this is the case where I actually am at this 1 by 1 grid, and what I want to do is I want to just fill this in. So what I do first is I will fill in this top right number because this I know has to be the smallest, because remember this grid also has to be a special grid, so top right is the lowest. Then I increment my number, then I do bottom right, increment, bottom left, increment, and then top left and increment. Then I return here. So basically, after I do this, basically what will happen is that 4 numbers will be filled in this grid. And this is the smallest possible case that I want to consider as I am going through this grid. Then I'm going to go to the top right. And remember, for the top right, what I want to do is I'm going to keep my top the same, but I need to adjust my bottom. So I'm going to use the formula of top plus bottom divided by 2 to get my new bottom. I also have to update my left value. And remember, for left, we're going to do the same thing, the boundaries divided by 2, but also add 1. Then I keep my right value the same. So for the bottom right, I need to adjust my top and bring the top down. So what I'm going to do is top plus bottom divided by 2. And remember, for the top formula, I need to add 1. I keep my bottom the same. Again, I need to update my left. I'm going to do left plus right divided by 2 plus 1, and then keep my right the same. So for bottom left, what I want to do is again update my top. So I do top plus bottom divided by 2 plus 1. Keep the bottom the same. In this case, I'm keeping the left the same because I'm actually bringing the right value over. And to bring the right value over, I just do left plus right divided by 2. And then for the top left, what I'm going to do is I'm going to keep my top the same. I need to bring the bottom up. So I do top plus bottom divided by 2. Keep my left the same. And then I'm going to bring my right over by doing left plus right divided by 2. Then what I actually do to call this is I'm going to call this with my initial boundaries. So the top will initially be at 0. Now the index for the bottom is going to be 2 to the n minus 1. So you can imagine in this case where we have n equals 3, we have 8 elements, but the top index is going to be 7 because it's a 0 indexed array. So I want to do 2 to the n, which is 8 minus 1. Again, my left will be 0 since it's at the left boundary, but my right will again be 2 to the n minus 1. And again, I will have 8 across, but only 7 indices. So I want to have this index be 7, so it's 2 to the n, which is 8 minus 1. And then finally pass in my grid. Then at the end, I will have filled in this grid, so I just return it. So let's submit and make sure that this works. And it does work. So this is a pretty cool problem. I would say the implementation of this was quite tricky and took me a while to figure out. So if you're struggling, don't worry too much about it. It's just kind of practice to get this kind of problem. Hopefully this is helpful and it made sense. If you liked the video, please like and subscribe, and thank you for watching.